Hey everyone, welcome to The Cosmic Theist. What is truth? Those are the rhetorical words that Pontius Pilate asked Jesus Christ, and that's what we're going to try to ascertain today. Well, no, as a matter of fact, I think we are going to ascertain it because that's what I promised you in the first video. The basic point here is that today's 21st century science dovetails perfectly with biblical history. Now, I'm going to unpack this and try to explain it. In our last episode, we read through the first chapter of Genesis, the 6 days of creation. And I told you it was 6 days, and it was also 15 billion years. I'm going to explain to you exactly how that's absolutely 100% correct. And I'm also going to go off on a little tangent here and say, the young earth creationist guys that think that the earth and the universe is 6,000 years old belong over there in the corner with the flat earthers and the moon hoaxers, okay? Gotta say it. I'm sorry, I have to say it. They're out there. And some of these guys have PhDs in astrophysics and they still want to deny what is right in front of them. What's right in front of them? Let me explain it. Where does our story begin? Well, I guess over the last few hundred decades, or not decades, centuries, okay? Centuries, I meant to say centuries. Secular scientists have clung to the idea and they have believed that we have what is called a static state universe. In other words, it's eternal. It's always been, it's here, it's always been the same size, it's been here forever, it will be here forever. As a matter of fact, when I was a kid, I remember watching Cosmos on the Nova, it was on Nova, it was Cosmos, it was on the public channel, and Carl Sagan, some of you that are old enough to remember, Carl Sagan was the host. He was the Neil deGrasse Tyson of his time. Personally, I think both of them were shills for the progressive liberal left, especially Neil deGrasse Tyson, but I digress. So Carl Sagan would start out Cosmos and he would say, the universe, all there ever was, all there is, and all there ever will be. And that was 1980. I remember clearly. That was 1980. Why he was professing such a falsehood in 1980 when we knew long before that that was not the case, well, it kind of makes you wonder. So, where does this story start? Where's my my marker? It starts earlier than this. It starts all the way at the very beginning, but we covered that last week. It starts in 1916. Now, what happened in 1916? In 1916, Albert Einstein published his general principle of relativity. You may know it as E equals mc squared. We've all heard of that. We all know about that. It took him about a decade. The revelation started to come to him in 1905. He completed it by 1915, and then in 1916, he put it out. However, what some of you may be unaware of is part of Albert's equation indicated to him that the universe was expanding. It was getting larger. It was growing. Well, the obvious implications there is if it was growing, that means at one time it was smaller and at one time it had a beginning. And for whatever reason, I haven't read any biographies on Albert Einstein, but he couldn't deal with that. He didn't want to deal with that. He didn't want to deal with, I think, the theological implications of a beginning. Because as you saw last week, when we read through the first chapter of Genesis, the first line is, in the beginning, God created the heavens and the earth. And here Albert, back in 1916, comes up with this general principle of relativity, and part of his equation validates that. So, unbeknownst to many of you, Albert put in a fudge factor in his own equation, which would maintain the static state universe. And that held fast for a while because there aren't too many mathematicians that are going to tell Albert Einstein he didn't get it right, okay? How long did that last? I'm glad you asked that question. It lasted until 1929. Now what happened in 1929? Another guy who you might have heard of, he was an astronomer. He came along. His name was Edwin Hubble. And out on Mount Wilson in California, looking through his 100-inch telescope, he's looking at galaxies. Okay? Let me just write that down. Edwin Hubble. You might want to look him up if you get a chance. So he's looking at galaxies, and he's taking pictures, and he took pictures using the color spectrum, and what he found was the galaxies had a red shift to them, which means they're moving away. They're all expanding and moving away. Now, if they had a blue shift, that would mean they were coming towards. They were getting closer, but everything was expanding. So he gets on a phone and he calls up this guy over here, Albert Einstein, and he says, "Hey Al, I think you might want to come out and take a look at this because according to my calculations at what I'm looking at through the telescope, we live in an expanding universe." So Albert Einstein acquiesces. He goes out to California. He gets, that's the wrong way. He goes out this way, and he goes out to California, okay? And he looks through the telescope. He sees the red shift. He already knew, secretly he knew. And he admits it. Not only did he admit it, he did an interview with the New York Times and said one of the biggest colossal mistakes of his life was putting the fudge factor into the general principle of relativity in order to maintain a static state universe. So he admitted it's expanding. I proved it. I knew it. Edwin Hubble exposed it. So what does that mean? If you've got galaxies flying away from each other, everything's expanding, then obviously natural physics would indicate that if they were expanding, they were at one time closer together. Now, if we move forward in time to the modern era, to the 21st century, where we have the Hubble Space Telescope, named after Edwin Hubble, and we have the Kepler Space Telescope, named after Johannes Kepler. You might want to look him up too. And we have the Planck satellite, okay, that's named after Max Planck, the father of quantum physics, okay? All three of these satellites and telescopes are awesome technology at looking at the universe. So, I think they used the Planck satellite to map the cosmic background radiation, okay? It's known as CBR. It's actually the afterglow of what is commonly referred to as the Big Bang. Very bad name. Not a good name for it, and I'll get into that in a little bit. Let me backtrack over here. Let's talk about E equals mc squared and how that plays a role in our 6 days of creation and our 15 billion year old universe. To give you an idea of how the principle of relativity works, what Einstein discovered was that space and time are connected. They are one and the same. They are inextricably entwined with one another. I'll give you an example of how this works, and we will put a link below that will to another website that will explain it in layman's terms, because I'm not an astrophysicist with a PhD. And although I understand the principle of relativity, I'm not that great at really explaining it, but I'll try. Let's say we're on the Earth, right here. Okay, this is the Earth, and we're going to go over here. That's Alpha Centauri. Alpha Centauri, as some of you may know, is the closest star to the Sun. It's 4.3, pretty close by cosmic standards, 4.3 light years away. In other words, at the speed of light, it would take 4.3 light years to get there. So, we'll get in our little spaceship, all right? Looks like this. There's your warp nacelles, right? That's the Enterprise down there. Okay, and we're going to take off, and we're going to go at a leisurely pace. We're going to go at the speed of light. It's going to take us 4.3 years to get there. We transit Alpha Centauri, and we head back at 4.3, or at the speed of light. Now, when we get back, how old are we? Or how many years have we aged? Well, we've aged 8.6 years. But on the Earth, time has moved faster, because the closer you get to the speed of light, the more time slows down for you, the more it speeds up. Or it doesn't speed up, it's all relative. No pun intended. When you get back, 17.9 years have passed. So you've aged 8.6 years traveling at the speed of light to Alpha Centauri and back. When you get back, all your friends, your relatives, your co-workers, your acquaintances, they're older than you. They're 17.9 years old. That's the principle of general relativity. Now, how does that factor into what it was that I was explaining, that the 6 days is also the 15 billion years? Well, let me explain. Let's erase all this off of here. Am I moving too fast, Ian?
No.
Okay. So, Edwin Hubble and Albert Einstein agreed with him, and now we know for sure, beyond a shadow of a doubt because of our modern technology, that we live in an expanding universe. And this universe had a beginning. Okay? So, we track the galaxies back at the speed that they're traveling, and it all converges in a single point, a quantum singularity. That's a subatomic, that's at the subatomic level. A small quantum singularity with the density and the gravity and all of space and time and everything is condensed into this quantum singularity, which is the smallest thing you can possibly imagine. Smaller, certainly smaller than a mustard seed. Now, what's out here? What's beyond all this? Well, there's nothing. And when I say nothing, nothing is what rocks dream about. Nothing. It's hard for the human mind to even grasp what nothing is, because we only know something. So I'm not talking about empty space, I'm talking about nothing. This was the universe, this quantum singularity. All time and space was encased in there. This tiny kernel of nothing, all right? Now, there was an immediate expansion, and then an expansion faster than the speed of light. Current physicists estimate, based on the cosmic background radiation, all of their measurements, these guys say that it's 13.9 billion years ago that this started to expand. Now, how fast did it expand? Faster than the speed of light. But for our purposes, we're going to use the speed of light because it'll be much easier to understand. How fast is the speed of light? Well, many of you may know that's 186,000 miles per second, okay? And it's easy to understand if we go by per second. So that means in the first second of expansion, the quantum singularity, and there's nothing here, okay? This is it. This is the universe. It's way smaller than that dot, I can tell you that. Begins to expand. And in the first second, this thing has expanded 186,000 miles in every direction. That's 1 second. Now in 2 seconds, it's gone another 186,000 miles in every direction. And what's 186 times 2?
About 400,000.
Let's round it up to 400,000. So in 2 seconds, our universe, which was a quantum singularity, is now 400,000 miles wide in diameter?
Roundabout, yeah.
In 2 seconds. We can get crazy and go for 3 seconds, but I think you'll start to get the point. How big is it in 3 seconds?
600,000.
600,000 miles in diameter. Okay. There's still a lot of gravity here. I would go so far as to say light hasn't even escaped from gravity. Anyone that knows about black holes knows that a black hole has such dense gravity that not even light can escape. But I'm getting ahead of myself, and that'll be in the next episode. The point is, that's 3 seconds, and that's how big it is. Now, let's extrapolate that out over 60 seconds. That's 1 minute. Now we're getting pretty big. Let's extrapolate that 1 minute 60 more times. Now we've got 1 hour. Now let's add another 24 to that, and we've got 1 day. I think you're starting to get the point. The universe is expanding at a rapid rate. It's huge. Now, take it out over 6 days. And what do you got? Well, I'll tell you what you got. You got what our modern day physicists and all these brilliant genius guys have estimated to be a 93 to 94 billion light year, the distance light travels in a year, light year wide universe. All right, and if you can, I'd like you to put up a shot of the cosmic background radiation, which is actually the afterglow of the, well, for lack of a better term, we'll say Big Bang. As a matter of fact, let me address that right now. Big Bang kind of sounds like a big explosion, doesn't it, Ann?
Sure.
Like a grenade going off. It's a big bang. That's not what it was at all. It really should have been, or really was, and anyone that knows anything about astrophysics or astronomy will tell you, it was a giant expansion, a stretching of space and time. I spelled it wrong. Anyway, you get it, stretching. So it's more like expansion and stretching. It truly was, and this is the right way to put it. It was the cosmic creation event. That's the proper term. Not writing too good there, but you get the idea. It was the cosmic creation event. So let's forget about Big Bang. That's a bad name, but it stuck. It was a big expansion, the stretching of the cosmic creation event. And it ended up over here with a 90, so far, it actually might even be bigger than that, a 93 to 94 billion light year wide universe. So, the question comes in, we know scientifically and irrefutably that there was a beginning at the instance of the quantum singularity. And what does the first line of Genesis say? We read it last week. It said, in the beginning, God created the heavens and the earth. Well, we do know one thing. Something had to cause this. There always has to be a first cause. And since we know that everything else was nothing, we have to have a causal agent. Okay, causal agent. And that causal agent obviously exists outside of the space and time in the quantum singularity, in the nothingness, if you will, but outside of, it's transcendent, in other words. It's transcendent of space and time. What would a causal agent that's transcendent of space and time, outside of our space-time continuum, what does that sound like that created the universe? What does that sound like to you? That, to me, that sounds like a scientific definition of God. Now, if there was no Bible or Old Testament or Genesis describing this, then I would say, well, you can call it whatever you want. But 4,000 years ago, they already called it what it was. It was God. And now, 4 millennia later, it all comes out in the science. Okay? It's God. God created this expansion. Now, I just want to make clear, we're using, remember the example of going to Alpha Centauri. We're traveling away from the quantum singularity at the speed of light. Each second, we travel 186,000 miles. So by the time we get out here, we've traversed 93 billion light years. All right? Now, if we were to travel backwards, because we know from our trip to Alpha Centauri that time is different when you exceed the speed of, when you approach, achieve, or exceed the speed of light, this trip in this direction would be 15 billion years. In this direction, we're counting it out by seconds, minutes, hours, and days. And it comes out to be 6 days. Now, I said over here, it was 13.9 billion years, or age of the universe. And I said in the first video, that's pretty close. Modern science is really good. We're close. It's rounded up to 14, and we're only off by 1 billion years. Now, why do I say that Scripture says it's 15 billion years? Because the math proves it out. You might ask me, well, the math proves it out? What are you talking about? Well, math is a universal language, all right? So, dig this. Let's take 15 billion years. All along with me. That's going to be, that's 15,000, 15 million. Is that 15 billion here?
Yeah.
That's 15 billion.
Yeah.
Okay, that's 15 billion years. Pretty close to what science is saying what it is. As a matter of fact, I mean, you can find astrophysicists that will argue it, and they'll say, well, the universe is anywhere from 10 to 20 billion years old. Okay, 15 billion divided by 1 million What is 1 million million? 1 million is the 1 million million is the amount of time it took from the quantum singularity to where we're at now. So you take 15 billion divided by 1 million million. That's the expansion rate of the universe. And what does that equal? That equals 0.015. All right? 0.015 times 365 days in a year. What do you suppose that comes out to be? 6 days. And that is how the 6 days of Genesis and the 13.9, or actually 15 billion, coexist using E equals mc squared. In the next episode, I'm going to get into this deeper, because you're going to say, well, on the first day God created light, and then when did the animals come in? Going to show you all that in exquisite detail. If this information interests you and you want to see the next one and you're kind of intrigued a little bit, then be sure to like, share, subscribe, hit the notification button, and until then, good luck and God bless.